There is a moment that happens in almost every family gathering, and you have probably lived it more than once without ever thinking about what it actually means. Someone at the far end of the table says something. Everyone laughs, and you did not quite catch it, so you smile along, or you ask them to repeat it, or sometimes, if you are being honest, you just let it go. You tell yourself it is nothing. Background noise, a mumbled word, a bad angle. Here is what almost nobody tells you about that moment. Your brain did not just miss a sentence, it just did a small amount of extra work you never asked it to do. And it does that same extra work thousands of times a day, every single day, for years, without you ever noticing the cost. The question we are actually answering today is this. What is the specific mechanical and neurological relationship between hearing loss and long-term brain health? And why does one of the largest bodies of dementia research in the world now treat untreated hearing loss as the single largest modifiable risk factor for cognitive decline, ahead of things people worry about far more, like diet or blood pressure? Not a vague correlation, an actual mechanism. One that plays out inside your skull every time you strain to catch a word. By the end of this, you will understand exactly how that mechanism works, and exactly why it has stayed so quiet in most conversations about aging and the brain. I have been wanting to make this video for a while, because the amount of attention paid to this connection is, frankly, embarrassingly small compared to how significant the finding actually is. If this kind of explanation, the kind that goes looking for the actual mechanism instead of settling for a headline, is useful to you, that is exactly what this channel does. So stay with me. Let me start with the finding itself, because I want you to sit with the actual scale of it before we get into why it happens. Over the past several years, a major international body of dementia researchers, the kind that periodically reviews the entire global evidence base on what actually causes cognitive decline, published an analysis identifying the specific modifiable risk factors most strongly associated with dementia later in life. Modifiable, meaning something a person can actually influence, as opposed to fixed factors like genetics or age itself. Hearing loss came out at the top of that list. Not near the top, at the top. Larger than physical inactivity, larger than social isolation on its own. Larger, in the modeling, than several of the cardiovascular risk factors that dominate almost every conversation about brain health and aging. And here is the part I find genuinely strange when I think about how little airtime this gets. Ask most people what damages long-term brain health, and you will hear about diet, exercise, sleep, maybe blood sugar. Almost nobody mentions their ears. Hearing loss gets treated as a separate, unrelated inconvenience, something you deal with by turning the television up a few notches or asking people to speak louder, entirely disconnected from anything happening inside the brain itself. That disconnection is not supported by the research, and I think it happens partly because hearing loss develops so gradually that most people never experience it as a single event worth investigating. And partly because it is genuinely uncomfortable to think about your ears and your brain as the same system. But physiologically, they always have been. So before we go further, I want to build the actual foundation here, because the mechanism does not make sense unless you understand what your brain is doing every single time you listen to speech, especially speech that is even slightly harder to hear than perfect. Here is the intuitive picture most people carry around, and it is wrong in a specific and important way. Most people imagine hearing as something that happens entirely in the ear itself, a kind of passive reception. Sound waves come in, the ear detects them. Done. Under that picture, hearing loss is simply a volume problem. Something gets quieter, and the natural fix is to make things louder. That is not how it works, and the truth is considerably more demanding on your brain than that picture suggests. Sound does begin in the ear, through a genuinely elegant piece of biological engineering. Sound waves travel down the ear canal and vibrate the eardrum, which passes that vibration through 3 tiny bones in the middle ear, and from there into the cochlea, a spiral, fluid-filled structure in the inner ear lined with thousands of tiny hair cells. These hair cells are the actual sensory receptors, and they convert the physical vibration of sound into electrical signals your nervous system can use. But here is the critical detail. The ear does not interpret language. It does not understand a single word. All the cochlea does is convert vibration into raw electrical signal and hand that signal off to the auditory nerve, which carries it up into the brain. Everything that actually matters, distinguishing one word from another, separating speech from background noise, understanding meaning, all of that happens deep inside the brain itself, primarily in regions of the temporal lobe dedicated to auditory processing, working in close coordination with areas responsible for attention and working memory. This is the part that changes everything about how you should think about hearing loss. When the hair cells in the cochlea start to degrade, which happens gradually and almost universally with age, largely due to decades of accumulated noise exposure and simple cellular wear, the raw signal reaching the brain becomes less complete. Certain frequencies, particularly the higher frequencies that carry a lot of the crispness and clarity of consonant sounds, the differences between a T and a P, an S and an F, start to drop out first. The brain is now receiving a degraded version of the signal, missing pieces, blurred at the edges. And the brain, being the extraordinarily adaptive organ that it is, does not simply give up and hear less. It compensates. It works harder. This compensation is where the actual mechanism connecting hearing loss to cognitive decline lives, and it has a name in the research literature. It is often described through something called the cognitive load hypothesis of hearing loss, and the idea is straightforward once you see it laid out. When the auditory signal reaching your brain is degraded, your brain recruits additional cognitive resources, specifically areas involved in attention and working memory, to fill in the gaps, to guess at missing words based on context, to actively strain toward reconstructing meaning from an incomplete signal. Neuroimaging studies using functional MRI have shown that people with even mild, untreated hearing loss show measurably increased activation in frontal brain regions associated with executive function and working memory during listening tasks, compared to people with normal hearing performing the exact same task. Their brains are doing more work, using more of that limited cognitive real estate just to accomplish the same basic task of understanding speech. Here is why that matters so much. And this is the piece almost nobody connects for people. Working memory and executive attention are not infinite resources sitting around waiting to be used. They are a shared, limited pool your brain draws from for essentially everything. Remembering a phone number for the next 30 seconds, following a complex conversation, holding a thought in mind while you finish a sentence, tracking where you put your keys while thinking about something else. When a meaningful portion of that limited resource gets redirected, day after day, year after year, toward the basic task of decoding degraded sound into words, there is measurably less of it available for everything else your brain is supposed to be doing at the same time. Researchers sometimes describe this using a term borrowed from cognitive psychology: cognitive load. The idea that mental resources devoted to one demanding task are simply not available for another. Untreated hearing loss, on this model, functions as a kind of chronic, low-grade cognitive load, quietly siphoning off resources that would otherwise go toward memory formation, sustained attention, and general cognitive reserve. Think about what this actually looks like across a single ordinary day, because the abstraction of cognitive load becomes much clearer when you picture it in real moments. A conversation at breakfast where half the words come through slightly blurred, and your brain spins a fraction of a second longer than it should, reconstructing what was probably said based on context and lip movement and general guesswork, rather than simply hearing it cleanly the first time. A phone call where a name or a number gets missed because a particular frequency range dropped out of the signal entirely, and asking the person to repeat themselves feels like a minor social cost not worth paying every single time. So sometimes you simply let it go and hope the context fills in the gap later. None of these moments feels significant in isolation. Each one costs perhaps a second of extra cognitive effort, a small tax paid without noticing. But multiply that by dozens of conversations a day, thousands of small reconstructions across years, and you begin to see how a genuinely enormous cumulative cognitive cost can hide inside something that never once felt dramatic enough to be worth mentioning to anyone, including yourself. It also matters which specific frequencies tend to degrade first, because this is not a uniform dimming of all sound equally, the way turning down a volume knob would work. Age-related hearing loss overwhelmingly affects higher frequencies first, and higher frequencies happen to carry most of the information that distinguishes consonants from one another. The difference between a soft and a sharp sound, between similar-sounding words that only differ by their opening or closing consonant. Vowel sounds, which sit at lower frequencies, tend to remain relatively intact much longer. The practical result is a strange and specific kind of hearing loss, one where speech can sound present, sometimes even loud enough, while remaining genuinely difficult to parse into distinct words, particularly against any background noise. This is precisely why turning the television volume up often fails to fully solve the problem. Volume was never the primary issue. Clarity at specific frequencies was, and simply making an already blurred signal louder does not restore the missing detail. It just makes the blur louder too. I want to pause and open something here, because there is a specific number connected to this finding that gets repeated constantly online, and we are going to come back to it honestly in a few minutes, because the honest version of it matters more than the dramatic one everyone quotes. There is a second mechanism running alongside the cognitive load explanation, and it involves something researchers call sensory deprivation, and its downstream effect on brain structure itself, not just moment-to-moment cognitive effort. The brain, across its entire structure, operates on a fairly ruthless principle when it comes to allocating its own physical resources, something neuroscientists sometimes summarize with the phrase, use it or lose it, referring to the brain's tendency to prune and reallocate neural tissue that is not being actively stimulated. The auditory cortex, the region of the temporal lobe primarily responsible for processing sound, requires ongoing, rich sensory input to maintain its full structure and function over time. When hearing loss reduces the volume and complexity of signal reaching that region for years on end, structural neuroimaging studies have documented measurable volume loss and altered connectivity specifically within auditory processing regions of people with long-standing untreated hearing loss, compared to people with normal hearing or people whose hearing loss has been actively corrected with hearing aids. This is not the auditory cortex simply becoming quieter. It appears to be, at least in some of the imaging literature, undergoing a genuine structural change in response to years of reduced stimulation. And because brain regions are not perfectly isolated from one another, changes concentrated in one area can influence connectivity and function in adjacent and connected regions over time, including areas involved in memory consolidation. This principle of neural tissue reshaping itself around whatever input it actually receives is not unique to hearing, and understanding it through a more familiar example makes the auditory version easier to picture clearly. Research on vision loss has documented something structurally similar for decades. Regions of the brain that would ordinarily process visual information when deprived of visual input for extended periods, gradually become recruited for other cognitive tasks entirely, a phenomenon called cross-modal plasticity. The brain, in other words, does not simply leave unused tissue idle out of some kind of loyalty to its original assignment. It reallocates. Applied to hearing, this means the auditory cortex sitting quietly underused, decade after decade, is not a neutral, static situation. It is a region of the brain gradually losing the rich, specific stimulation that keeps its full network of connections intact. Connections that, once weakened, do not appear to snap back instantly the moment a hearing aid is finally introduced, which is part of why researchers increasingly emphasize the value of addressing hearing loss earlier, rather than waiting until it becomes severe enough to feel undeniable. There is a third piece worth mentioning, because it is less about the brain directly and more about behavior, though it circles back to brain health just as strongly. Hearing loss, especially when it develops gradually and goes uncorrected, tends to make conversation genuinely more effortful and less rewarding. And this has a well-documented tendency to reduce how much people participate in social interaction over time. Not because they suddenly dislike people, but because straining constantly to follow conversation in a group setting, at a restaurant, at a family gathering, is exhausting in a very literal, cognitively measurable sense, and exhaustion changes behavior. People with untreated hearing loss frequently withdraw somewhat from exactly the kind of rich, unpredictable, cognitively demanding social interaction that a large, separate body of research has repeatedly identified as protective for long-term brain health. So you end up with hearing loss potentially contributing to cognitive decline through at least two direct neurological pathways: chronic cognitive load and structural changes from reduced stimulation, while simultaneously reducing exposure to the social engagement that would otherwise help protect against that same decline. Three converging pathways, not one single mechanism, all pointing in the same direction at once. It is worth being specific about why group conversation in particular carries such outsized cognitive value. Because it is a genuinely different task from a quiet one-on-one conversation and demands considerably more from an already strained auditory system. A group setting requires rapidly tracking who is speaking, adjusting to different vocal pitches and speaking speeds in quick succession, filtering out overlapping voices and background noise simultaneously, and following a thread of meaning that can shift topic and speaker every few seconds. This is precisely the kind of cognitively rich, unpredictable mental exercise that researchers studying cognitive reserve have repeatedly found associated with better long-term outcomes, not because conversation itself is magic, but because it demands rapid, flexible, multi-system engagement that few other everyday activities replicate quite as naturally. When hearing loss makes exactly this kind of setting the most exhausting and least rewarding one to be in, it is often the first type of social engagement people quietly begin to avoid, which means the specific interaction most protective for the brain becomes, for many people with untreated hearing loss, the one they experience least. Now, the honest part, because I think you deserve the real shape of this evidence, rather than the version that gets flattened for a headline. You may have seen a specific claim online stating that hearing loss increases dementia risk by a fixed, dramatic percentage, sometimes quoted as high as several 100% for the most severe cases, presented as though it applies uniformly and precisely to everyone with any degree of hearing loss. That claim traces back to real research, specifically long-term cohort studies that did find substantially elevated dementia risk associated with hearing loss, with the association becoming stronger as the severity of hearing loss increased. But the specific, dramatic percentage figure that circulates most widely online has, in a lot of the content repeating it, been stripped of the fact that it applied specifically to the most severe category of hearing loss in that research, tested against a comparison group with completely normal hearing, under specific statistical modeling assumptions that do not translate cleanly into a universal multiplier applicable to everyone with any degree of hearing difficulty. The actual, more careful body of research shows a consistent, meaningful, dose-dependent relationship, meaning risk tends to increase in step with the severity of untreated hearing loss, which is genuinely significant and worth taking seriously, without needing an inflated round number to make the point. I would rather you walk away from this video with the real, more careful version of this finding than with a statistic that will not survive being looked up. I also want to be fair to the complexity here, because this is not a fully settled, closed case in the way some content presents it. Establishing that hearing loss and dementia risk are strongly associated is different from proving, with absolute certainty, that hearing loss alone directly causes dementia in every case, and researchers studying this area are appropriately careful about that distinction. Hearing loss and cognitive decline share several risk factors in common: age itself, cardiovascular health, general frailty, which makes it genuinely difficult to fully separate a direct causal pathway from a shared underlying vulnerability that produces both problems somewhat independently. This is an active area of ongoing research, and some of the strongest evidence for a genuine causal, not just correlated relationship, comes from a different angle entirely: intervention studies, which we will get to in a moment, because they offer some of the more convincing evidence in either direction. There is also considerable individual variation that a single headline statistic can never capture. Someone who developed hearing loss gradually, but sought correction early, wearing hearing aids consistently for most of their waking hours, appears to carry meaningfully different risk than someone with an equivalent degree of measured hearing loss left entirely uncorrected for a decade or more. Cognitive reserve, a concept researchers use to describe the brain's accumulated capacity built through education, occupational complexity, and sustained mental engagement across a lifetime, also appears to modify how much impact a given degree of hearing loss actually has on long-term cognitive trajectory. Meaning, two people with identical audiogram results can reasonably expect somewhat different outcomes, depending on factors well beyond their ears alone. None of this weakens the underlying mechanism we just walked through. It simply means the honest answer to how much this matters for any one specific individual is genuinely more nuanced than a single multiplier applied uniformly to everyone. Let me walk through what those intervention studies actually found, because this is where the research moves from simply observing an association to testing whether doing something about hearing loss changes the trajectory. A large, well-designed, randomized trial published in recent years specifically tested whether providing hearing aids and structured hearing support to older adults with hearing loss slowed cognitive decline compared to a general health education control group. The overall result across the full study population showed a modest effect. But when researchers looked specifically at participants who were already at higher risk for cognitive decline going into the study, the group already showing early signs of accelerated cognitive aging, the hearing intervention group showed meaningfully slower cognitive decline over the study period compared to the control group. That is a genuinely important distinction. It suggests that addressing hearing loss may matter most, and most measurably, for people who are already vulnerable, rather than functioning as a universal, guaranteed protective measure for absolutely everyone, regardless of their starting risk profile. Let us talk about the everyday patterns that quietly make this worse, because there are a few extremely common behaviors that extend the timeline of untreated hearing loss far longer than most people realize. The most significant one is simple delay. Population-level data on hearing aid adoption has consistently found that people wait, on average, several years, sometimes close to a decade, between first noticing meaningful hearing difficulty and actually seeking treatment or being fitted with a hearing aid. That gap is not because people fail to notice. It is because hearing loss develops so gradually that each individual week feels unremarkable, and because there remains a genuine, if often unspoken, social discomfort around hearing aids that does not exist to nearly the same degree around glasses, despite the underlying logic of correcting a degraded sensory signal being functionally identical. A second common pattern is compensating environmentally instead of physiologically. Turning the television up, sitting closer at gatherings, asking people to repeat themselves, all of which manage the symptom moment to moment without addressing the underlying signal degradation the brain is still working overtime to compensate for. A third pattern, subtler than the others, is gradually narrowing the range of social situations attempted at all. Quietly avoiding noisy restaurants or large gatherings, specifically because following conversation there has become exhausting, which, as we discussed earlier, removes exactly the kind of socially and cognitively rich engagement that appears protective for brain health. So, what does a more sensible approach actually look like here? And I want to be clear that this is simply the practical implication of the mechanism we have walked through, not a medical directive. The core implication from this body of research is straightforward. Treating hearing loss earlier rather than later appears to matter, both because it may reduce the years spent under chronic cognitive load and because the intervention research suggests the benefit may be strongest precisely when addressed before significant cognitive vulnerability has already set in, rather than waiting until decline is already underway. A formal hearing evaluation from an audiologist, not a general assumption based on how loud the television has gotten, is the starting point that produces an actual, measured picture of which frequencies are affected and to what degree, rather than a vague sense that things have gotten harder to hear. For people already using hearing aids, consistency of daily use matters considerably more than most people assume. Research on hearing aid benefit consistently shows the protective association is strongest among people who wear their devices during the majority of their waking hours, not occasionally or only in specific situations, because the brain's exposure to a clearer signal needs to be frequent and sustained to meaningfully reduce the chronic cognitive load we discussed earlier. I do want to be responsible here about who this information is most relevant for, and when a conversation with an actual specialist matters most. Anyone noticing consistent difficulty following conversation in groups, frequently asking people to repeat themselves, or being told by family members that the television volume has become unusually loud, has a reasonable basis for a formal hearing evaluation with an audiologist. This is not a substitute for that evaluation, and it is especially not a substitute for medical attention if hearing loss appears suddenly, in one ear specifically, or alongside symptoms like dizziness, ringing, or ear pain, which can indicate a different underlying medical issue entirely and warrant prompt evaluation by a physician rather than routine hearing testing alone. I would genuinely like to know something before you go. Think about the people in your own life, maybe even yourself, who have quietly started asking others to repeat themselves more often, or who have started avoiding certain gatherings because following the conversation has become exhausting. Tell me in the comments whether this connection between hearing and long-term brain health was something you had ever heard discussed before today, because that response genuinely shapes which overlooked connection inside the body we take apart next. So think back to that moment at the table, the one we started with. The laugh you smiled along to without quite catching the words. It was never really about that one sentence. It was about what your brain quietly agreed to do, sentence after sentence, year after year, without either of you ever discussing it directly. Understanding that is not a reason to worry. It is a reason to finally have the conversation your ears have been trying to start with you for a while.